Thanks, Adam, for allowing me to speak here tonight. Tonight, I'm going to talk about from start to rest in 60 minutes. It's a talk around the Web API. It's not going to be specifically about REST or anything like that. It is going to involve REST, obviously, but I'm not going to go into the principles of REST too much. Just a little about me before I begin. Been an ASP.NET MVP for the last, I don't know, probably 5 or 6 years, coming up for a renewal in the next month, so hopefully I get in. Been an ASP Insider for a number of years as well. I've managed to author a few books. The latest one is .NET Performance and Optimization. It's available on Amazon. I encourage you to buy many, many copies. It's bound to be a timeless classic. Also the CTO of Sasu.com, which is online accounting software. It's all Australian-owned, very small company. That's where I've been for about the last 2 years. This demo, or actually this presentation, it's all code-based. There is a fair bit of code involved. I'm going to be bouncing around in code a fair bit, but it is. I did use the Azure websites. Show of hands, anybody? Nobody? Excellent. What I did with this is create a Git repository in Azure. It's all code-based, like I said. Pushed it up to the repository, and it gets automatically deployed. So if you've got internet connection, you can go and follow along at that web address there. It's all been pushed up, so you can actually follow through, or you can go straight to the end and have a look at the resources that are available there. Okay. So like I said, it's all code-based. So there is no PowerPoint presentation, but it kind of looks a bit very slidey. But once you download the code and there's no database involved, you'll get the whole experience as well. So I figured it was a bit of a waste of time just to come up with a PowerPoint preso. I was coming up with a demo, and then you'd write the Web API to talk to it, and it kind of looked the same. I thought, bug it. I'm a bit bored of PowerPoint, so I might as well write the demo and the slide deck in the same thing. So yeah, just going to talk about a brief history about kind of how we've got to the Web API and why we are where we are. Just some of the basic principles of REST, and specifically how the Web API is going to help us work with those. We're going to move on to some shiny awesomeness with all the features, and that's going to be a big sort of flyover of all the features of the Web API. It's not going to be sort of one progressive story where we'll build up the application at the very end. We're just going to hit some of the basics, and then we're just going to see all the different features. So like I say, I'm going to bounce around code a fair bit. All the access for the Web API is all done through JavaScript and jQuery. So if you're familiar with $.ajax, that's pretty much all we're doing to access it. So I'm not going to go into too much of that because there is a lot of code to look at. It kind of gets a bit boring. Finally, then we'll obviously wrap up. So Adam touched on this before. Where we started from in the .NET world as far as web services was good old ASYNC web services. They were good. They were the original. They were simple. They sucked up some XML and they spat out some XML. And they were pretty easy to use. They did have a lot of deficiencies, however, most notably security and things like messaging, addressing, and reliability and that kind of thing. So they all work kind of well, but everybody started to roll around security solutions. At about that time, or a little bit after that, the release of that, the web service enhancements come about. So the WS security standards started to come about, where we tried to layer on a formal security spec, affectionately known as WYSI. I didn't actually work with WYSI version 1, but 2 and 3 I did. And while they kind of worked, they were a little bit painful. They were very verbose, quite complex to get a handle on. Shortly after that, WCF came out, and that encompassed all the WS standards, encompassed almost all the standards. I think it's one of the few stacks that still implements pretty much everything. But while it was the Windows communications unified, you could do everything, TCP and MSMQ and various web bindings. A lot of people still weren't happy using it. It was sort of hard to configure, hard to get a handle on. The configuration was a little bit painful. It just wasn't as straightforward as what people would like. You can do REST in it, REST-based APIs, but it's just not as seamless as what you'd like. So consequently, people got a bit frustrated and they thought, hey, we really like MVC. MVC is very flexible. You can output pretty much whatever you want. So they come up with all these custom views to output, say, JSON and XML. Did a little bit of the code behind the scenes to do some formatting. So if you passed in a content type that you were after for XML, it would give you XML back, and the same thing for JSON. So it took a little bit of code, but it was remarkably simple, and there were a lot of people using MVC as their REST or their Web API. Also, a little bit about the same time as all this started to form up, the WCF team was looking at this thing called the WCFWebApi. So it was an attempt at making WCF nicer for REST-based services, to design services, create and consume them. And they were looking at these people building all these custom views and MVC, thinking, hey, that is pretty easy. And the stuff that we're building, you know, we're building content negotiation units, that's pretty cool as well. But still, this MVC approach has some merits. And so what they did is they thought, all right, we're going to not continue with WCFWebApi so much. We're going to take a lot of the principles and technology we've got with that, kind of merge it into the MVC way of doing things. And that's where the WebApi sort of come about. So it tries to merge the best of both worlds. So it kind of accepts the premise, you know, the simple is essentially the winner. That's what was one of the barriers to WCF. It wasn't so simple, whereas just using a known quantity, i.e., you know, what is available, HTTP, SSL, standard HTTP status codes. You know, like I said, everybody knew it, worked easy with it, comfortable. So they thought they'd just go with this kind of MVC-esque approach of building a REST API. They wanted to make sure they supported, you know, I guess, again, what everybody's familiar with, JSON and XML out of the box. You can optionally add your own. It's extremely flexible. But the WebApi will give you default support for those two formats. It does promote this resource-based way of defining your API. So instead of doing something like this, where you contact a host, contact, get one, which you say, look, I want to get contact with an ID of 1. It's all based off HTTP verbs. So here we've just got HTTP contact 1. If you issue a HTTP get, it will say, hey, you want to actually get contact number 1. If you issue a HTTP post, it will assume that you want to update or potentially insert contact 1. If you issue a HTTP delete, you'll want to delete contact 1. So you don't have, you know, multiple URLs with get, add, update. It's all just one URL with the action inferred from the HTTP verb. So all these items I've talked about, these first three here, they're all natively supported and promoted by WebApi. This last one here, this, I'm not sure how you pronounce it, but the HATOAS, hypermedia as the engine of application state. It's kind of a way of making your APIs self-discoverable, in that you might go to an endpoint, and from that endpoint, you'll get the results that you're after. But you'll also get information that will help you discover the rest of the API, what other resources are available for it. So from hitting one endpoint, you can literally branch out and go to other places in the API, and it all becomes a very natural flowing way of doing things. It's still very early, though. So the WebApi, again, doesn't natively support it. There is media types which you can add into the WebApi, which add a certain degree of support for it. Again, it's very early days. It does require a bit of extra work to get it to do what you want. But it is worth investigating, and you know, if you're coming up with an API now, it's worth keeping an eye on. There's no reason you can't create it a fairly, you know, simple API now and then add that kind of support later on. Before I jump into some code, is everybody familiar with MVC? Anybody not familiar with MVC or concepts thereabout? Because a lot of it's going to be very similar to MVC, so I'm going to refer to a lot of MVC concepts. So if you don't know them, it's going to be a little crappy. In the Web API, controllers will inherit from API controller instead of controller. There is a global configuration object where pretty much all the configuration of your Web API is held. And we're going to look at all this in code soon. It defaults to an API route, so if you don't do anything, you create file new project for the Web API, you'll get this kind of route by default. You can change all this, obviously, but this is what you get out of the box and without any effort. Again, HTTP method is inferred from controller actions. So I mentioned before, if you issue a HTTP get at a URL, it might be, like I said, host contact with a /of1, it'll want to get contact 1. And the way that it kind of wires up that request to your action method is it says, all right, well, have you got an action method that is at least called get or is prefixed with get? So I could have an action method called get stuff or get contacts or get something, and the Web API will take that HTTP get and wire it down to the action method and hook it all up for you. You don't have to really do anything. And it tries to match up the action arguments for you as well to get the correct method. So it's quite clever, and we'll see how all this works. Content negotiation, so automatic content negotiation. By default, you get support for JSON and XML. So if you just pass in a particular header that you want application XML or application JSON, the Web API will say, hey, no problem, I'll give you back what you're asking for. You don't really have to do too much. You can take out those, you can put in new ones. We'll see how that's done too. And also interception points, DI handlers are all very similar to MVC. They just have different entry points, I guess. But they're taking a really big slant towards everything async as well. So if you're not familiar with task-based programming, does everybody know what tasks are in the parallel library? Yeah? It's pretty much all that. So as long as you're familiar with that and sort of how to use that, it will make it a lot easier. It's not too dramatic to use, but it does take a little bit to get your head around if you're not too familiar. We'll just launch up to a quick demo. So this stuff is just going to be fairly simple, but just to demonstrate how the Web API hooks up things. Okay, so I've got a method here which is just going to access my host API simple. I'm going to jump into a code here just to give you a bit of context. Where are we? Simple controller. So I've got my simple controller. It inherits from API controller. You can see I've got a get method. I've got a get that's expecting an integer argument, another get with a text string argument, get me some beer and a few other things. So we'll just go and execute this guy. And I'll call up this window. So I'll execute do it, fairly simple request. There we go. So we've hit the method in there. Nothing spectacular there. If we have a look at the URI, oh, hang on, let me call it up. Okay, we're just accessing that URI. Again, nothing spectacular there, but it is hooking it up automatically for us in this method here. If I execute something else, say passing in a numeric parameter, say 1, 2, 3, I'll execute that. You can see 1, 2, 3 has been passed in for us. Again, kind of what you'd expect. But we haven't had to hook up any specific routes. Sorry, let me just call it up. There we go. All I've done in this instance is I've called that same URI just with a query parameter on there. So easy enough. Passing in a text parameter. We get some text that's been passed in. If we have a look at the URI on that one, all I've done is a different query argument. So the differently named query arguments, and in the first case I didn't have one, told the Web API where to route the action methods to. So again, we go back in code. I didn't have any query arguments on the first one. I had an ID query argument on the second one, and I had some text query argument on the third one. So we didn't have to place any special routes in there. It was just smart enough to go and redirect it there for us, which is all pretty cool. Makes life a little easier. Now, I don't know why Chrome keeps doing that. Now, what I'm going to do is see if I can call this. Device metrics. Good stuff. There we go. Beautiful. Thank you. Okay, so in this, I'm going to got a method here passing in kind of beer. So this time, instead of going to API simple, I'm going to ignore. I've got to going to go straight to beer kind of beer. So what I'm going to say is go. I like strong beer. You can say, get me some beer. The kind of beer is strong. That's all pretty good. But it wasn't the default API route. If we have a look at this call, again, we're looking at beer strong. So I didn't want to use, have API at the front of it. And the way I've done that is in my global ASYNC, where I set everything up. If I look at the API routes, I'm defining a HTTP route. So instead of like an MVC do a map route, I'm doing a map HTTP route. I'm just saying beer, and the parameter is kind of beer, and it's going to route it to the controller, which is simple, action, get me some beer. So I'm just defining something a bit more, what I would consider a bit more URL friendly there. So it's just a way of changing the default behavior. So they're all HTTP gets. In terms of posting and putting, so if I've got some data here, I'll say 1, 2, 3, post data down the pipe. And you can see here I've got a post method. I've actually got an object here. So this object, have a look at that. It has arg1, arg2, arg3 as 1, 1, 2, 2, 3, 3 that you can see there. If we have a look at the request that I did, you can see here it's the same URL. I'm posting, and if we go down, here's the parameters that I've got there. Okay, so I haven't really had to do anything to wire that up. It's managed to plop them into that that object for me. So it was smart enough to know, hey, there's arg1 in that JSON object. I'm going to put that into the object for that posted data there. So again, the Web API making it a little bit easier. One thing I didn't mention before was, let's say I'm going to call specifically the one that's expecting an integer, but I'm not going to pass any parameter in. It'll probably get an error. Yep, failed. If I have a look here. So I had ID equals, but there was nothing there, so it tried to put it into an integer parameter and failed. If you have a look at the response, you can see there's a JSON response there, which is usually the default. That's the first formatter on the top of the rank there. But I talked about content negotiation before, and that applies to errors, applies to pretty much everything. If I want XML, I'm going to execute the same request. It failed, which is what we expect. But you can see it's actually got XML response there instead of JSON. And the only difference was all this stuff here. So I'm saying, you know, I want application XML instead of JSON. Well, before I just, it had star.star, which is give me whatever is the first default. In this case, I was explicitly asking for XML. So again, we didn't really have to do anything to get that support. Web API does that for you. Okay, similarly with if I issue a HTTP put, you can see I'm accessing the put junk. So it wasn't just the put method, it was put junk. It inferred which one to, which action method to call, plopped it into data for me. Everything's good. Again, just to verify. Same URL, different method. Finally, a head request. It's called into head of cat herding. So again, just looking at the prefix of the action method. And just to prove that that was the case. Same URL essentially, but issuing a HTTP head verb. So again, this isn't particularly exciting, but it does give you an idea that the Web API has been quite smart about what's coming in, what verbs are being used, what action parameters it can discern, and rerouting that to your methods in your API, your API, your controller. And it's all about trying to make a nice, nice action parameters for you, so you don't have to, you know, start to pass strings and do all that kind of stuff if you're just doing sort of basic stuff. However, if you do want to do something a bit more, I guess, raw, we're going to go to this thing called host generic. So if I do that, so what we've done here, we're in the generic controller, and as our action parameters, we've got a HTTP request message, and we're going to return a HTTP response message. So there's no particular parameters there apart from this one generic blob. And in this instance, I'm going to let that run through. I'm going to pick apart a bit of the body. I'm going to create a string. And then from that request, I'm going to create a response that's going to contain a string. I'm going to give it a status code of OK, which is 200. Give it a string body that it can return. In addition to that, I'm going to add some headers, web server, Glover's bald, the age header, and return that response. And if we have a look at that request, let's go down here. Response headers. You can see it put the age in for me. Glaver's bald. Where are we? Web server, web 1. So we got down and sort of modified the headers. We had more direct control over the message that was being returned. So again, it's still quite easy to just provide a different parameter on there, being this generic HTTP request message, and you can do a hell of a lot with the response as well. Is everybody okay with that so far? Just bouncing around a fair bit. Again, as I mentioned, I'm just going to sort of fly over a lot of these features. So it's just the idea being we're going to cover a lot of it. And so when you get to actually using the Web API, you'll at least have an idea of what it can do, what it can't do, and perhaps what things to investigate further. And again, all this code, there's a link at the end that you can download and run it pretty easily on your Lappy. Okay, I should prefix this by saying a lot of the concepts, things like model binding, are very similar in the Web API than they are in MVC. However, the two are distinctly separate. One doesn't rely on the other. The Web API takes no dependencies on MVC. So a lot of the things you'll see in the Web API appear to have been copied, or they use similar but different ways of doing things, and you can't sort of just, let's say, set up DI in MVC and have that just propagate to your Web API as well. You actually have to do it separately. The things they use are extremely similar, and you think, well, it's just like kind of a doubler. It's a bit of a waste of time. But they did want to make a conscious effort to take no dependency whatsoever on MVC, and you'll be able to do things like self-host your Web API without IIS. You can host it in a console app, and you can do a whole bunch of other things with it as well. So we saw how some of the parameters were getting routed into the action methods and arguments for us. The simple types that you saw there will generally use this thing called model binding, which you're probably familiar with in MVC. And it's a way that the Web API provides a way of reading into messages, picking out things for you, and just whacking into arguments. You can create your own model binders, and we'll see how we do that later on. However, complex types, when I say complex types, you might have an object that contains an object that contains an object in your action parameters or action arguments. We'll default to this thing called media formatters. And so the media formatter, because it's a complex type, it expects to see it in the body of the message. And the media formatter usually relies on the content type. So if it's application / my special type, it'll expect a particular media formatter to rehydrate that complex type for you. Because if it's too complex, it doesn't know how to pick it apart and put it into an object. So it kind of expects you to put something there for you. Media formatters will always want to read data from the body of the, say, the post, for example, whereas model binding will take it from the URI or from the body. But you can change all that using these attributes, and this will all make a bit more sense later on. One important thing to note out of all of this is in the Web API, if you ever read the message body, you can only do it once. If you try and do it without taking a copy of it, the data won't be available to any downstream components, and so we'll see an instance of this later on where you go and read the data, you'll read the body, and you think, hey, that's cool, I'll go log it in database. Then it goes down to action methods, and suddenly it's all null. You think, what the hell's going on? It's important to know that you can only read it once. You need to take a copy of it if you're going to do that when you're in some of the interception points in the stack. But again, I'll explain or demo that a bit later on. And again, if there's two complex types as action parameters, complex types will require default to using media formatters, which read from the body. Because you can read from the body only once, the first one might get populated, the second one won't. So if you've got two complex types, I mean, fairly complex objects, you need to say, well, one's got to use model binding, and I need to provide a special model binder and those kinds of things. So if you're going to get particularly nasty with some of your action methods and have complex objects sitting on there, you might run into some issues. You need to think about these kinds of points. So in terms of a pipeline, this is very simplistic, but we have something called a delegating handler, which sits at the top of the stack, and underneath that we have these media formatters, which I mentioned previously. A delegating handler, in contrast to a media type formatter, will just take in all requests, and it's not really concerned about whether it's at JSON or XML or whatever the hell it is. It just takes it and it says, here's the request, go and do something with it if you choose to. By contrast, media type formatters will want to operate on a specific media format type, be it JSON or binary or octet or anything like that. So the delegating handlers are pretty handy for things if you're logging Web API usage. You might just want to log the incoming, it gets processed, and then log the outgoing for auditing purposes, perhaps some authorization and security, that kind of stuff. Media type formatters, this is where if you're going to define your own custom type. So if you're just using JSON serialization and you've got your own custom objects, you probably just want to use model binding to stuff that into an object. But if you've got application / my special custom type, and you're defining some weird and wacky format that you're posting down the pipe, could be some form of binary, then you probably need to define your own media type formatter for that. All of these things are registered in the global configuration area. We'll have a look at all that soon as well. So I'm just going to have a look at the delegating handler first, which is the first one in the stack that we saw. So all this particular thing is doing is just showing us the statistics that we've done in this particular demo. You can see these URIs that I've hit, how many times, the status codes that were issued. You can see the bad requests that I forcibly did before. Nothing too sexy about the output, but let's go have a look at how that's all done. So we'll go from the very top where it's all hooked up. If I have a look here, I've got an API usage logger that I'm adding into the global configuration message handlers. Just adding an instance of that. If we have a look at that, it's a class that inherits from delegating handler, and all it really does, I'll get this out of the way, is override one method, which is send async, and that passes in a request message and a cancellation token, which is specifically related to tasks. And you can see here it's returning a task of type HTTP response message. Not a response message, just returning a task. So the Web API is going to say, hey, you've given me a task of response message. I'll take that and I'll execute it asynchronously for you and make sure that the response gets back. But the reason it's taking this very task-based approach is that it's a huge increase in scalability. It's not synchronous going in and synchronous going out, and you hold up this I/O thread. It takes a task. You can go off and do other stuff with it. As an I/O thread is released and the extra processing, extra requests are done, and when it's finished with the task itself, it also takes another task back and synchronizes that to the original I/O request and comes back to the response. It looks synchronous from a consumer point of view, but under the covers, there's all these threads being spawned off, and it's doing it in a very asynchronous and very scalable manner. In this particular instance, I'm just extracting the logging info from that request. I then say, okay, go execute that, and that response that gets sent back is a task. And with that task, I'm going to say after the Web API is, after you've done with it, here's a continuation to extract the response from it. Okay, so you get the incoming. We tell the framework to go and do its thing. It gives us back a task, and with a response, I'm going to extract the information from that. If we have a look at that, all it's doing, really, it's just adding various items to the web cache, and then I go and display that on the screen a bit later on. Okay, so if I execute here, if I put a breakpoint in there, it's not on. Why aren't you doing that? Okay, there we go, good. So actually what I'll also do is custom binding. It's calling into this get site statistics. So we've hit, let me just run that again, sorry. So we hit the delegating handler where it goes and executes everything and stores the statistics, and then it hits the get site statistics as you'd expect. So all I'm doing is putting an object fairly early up in the pipeline there. But I was speaking earlier on about, if you were to read the message body, this is where I'll demonstrate some of the caveats that you have to be careful of. So let me just stop that. So what I'm going to do here, good. So all I'm doing here is I'm creating a memory stream, and then with the request and the content, I'm going to copy it asynchronously to that memory stream with the idea that I'm going to read it, read the content to the end, and typically you might log it to a database or something. So I'll just run that up. And Adam made me copy this demo to this dodgy little machine here, so I'm not sure how fast it's going to run, but we'll see how it goes. Okay, so we've come in there. We're copying the stream away. Now we get to that response part. It's all good. Now, if I go to my original demos, next one, next one. Actually, if I execute this, here we go. Okay, so if I'm, let's say I was doing the post again, you saw that before I put in some numbers and all was good. Post started down the pipe, comes to there, executing the request, and it gets to my posted data, and it's got actually null in there. Even though I can assure you that we haven't changed the code, all I've done is tried to log it. So there's actually null coming through to, or nothing coming through to that action method. So, and you know, it's not an uncommon scenario where you might want to log that data, which is what I tried to do there. But in order to get around that, if I can work this keyboard, all I'm doing in addition to that now is load it into a buffer asynchronously and then doing pretty much the same, executing that within the continuation. So I'll run that again. So this might seem a little, I guess, not so much hard to grasp, but you know, not immediately obvious. But this actually took me a few days to get around. I was wondering why. Well, when I logged, you know, why is it doing this to me? I'm trying to log it into a database, and I'm reading the body, getting the body in the database, but going down the action method, nothing's there, and it took me ages to figure out. It was a real non-fun experience. So now if I post that down, we execute all that as you'd expect, and with any luck, yep, we've got the data back in. So very, very subtle. You know, it's not, that kind of thing isn't immediately obvious. So if there's only one takeaway when you go and use the Web API, remember to do that if you're ever going to do logging. I think most people would do some degree of logging. Now let me just take that out. Okay. So that was the delegating handler. That was high up in the stack. We weren't too concerned about the type of data that's coming in. We just want to get the data and we want to do some stuff with it. In this case, log it. Let's get rid of that.
One question.
Yes?
Sorry to, is the reason why you didn't override them and make them async, and why you're using continuations instead, because of the impact on testing, or is the overriding and making them async problematic with the Web API?
No, it fully supports that. It's just an extra overhead. With async, you know, you've got to introduce the await keyword and kind of await on it, and it's really not conducive to that. In order to work with the framework, you really should just be executing or doing everything in tasks and continuations and letting the Web API marshal that behind the scenes.
But it has impact on testing, though. For example, if you don't test it, you can't guarantee it'll complete at any time. If you're doing the async await, it manages all that for you. It's still doing the continuation, or continuation just the second half.
From a testing perspective, it depends how you mean testing the actual action methods themselves?
Yeah, for example, I mean, if you load the controller up inside an n-unit framework or something, you do the first half of the controller action, and then you can't tell when the continuation.
Yep, so you probably just wrap that. So the controller action, and we'll see this a bit later on, just returns a task, and it kind of implicitly does an async and await for you. So in calling that, you'd probably just wrap that in something that did async or awaited for it.
I was just curious why you won't use the keywords, but fair enough.
There's actually no need to. It's kind of almost redundant sometimes.
But, okay, maybe this is an axiomatic argument, but I personally prefer the async and await. It's a lot easier to read the code because you aren't dealing with continuation. applications. I mean, the only reason that I've seen to use it is in Metro WinRT when you actually have the apartment vetting issues.
Yep.
Where you have to use a continuation to force it back in that thread.
So I guess the ultimate answer is there is no hard and fast rule. You can absolutely use that. It fully supports that.
Fair enough.
Okay. So the next on the stack down is a custom media formatter, and in this case I'm going to pass through a content type of application XDodgy, and it's going to pass in this sort of pretty ugly looking data. So obviously that's not JSON, that's not XML, so we have to provide some sort of formatter for it, or it's just going to interpret it as kind of a string. So I'm going to go and execute that and take that breakpoint off. Oh no, sorry. Let that run through. When it gets finally through to my model, and I'll explain the path of how it got there in a second, you can see that I've got test, and my two attributes are Joe and Bodgy. So I put them into a nice strongly typed object from this. Took the name, attribute 1, attribute 2. So in order to achieve that bit of magic, like everything, global configuration, I'm adding a formatter, a new instance of a formatter. It's inheriting from a media type formatter. I'm going to say, hey, this is the media type that I'm going to support, and I'm adding that to the supported media types. And it's just a matter of overriding a few methods. In this case, I can read the type, but I'm not going to write to it. If you were doing something like JSON-P formatter, where you're outputting some sort of JSON-P data, you'd set true there to indicate that you're going to output some data. And finally, overriding the read from async. Again, it's returning a task of object. So all this task-based stuff is taking in a type, the read stream, the content, and a formatter logger. And for the most part, saying, all right, I'm going to return a new task of object. If the type that you're querying, so if the type of my action method is not of type dodgy model, even though the content types come in, I'm not going to process it. I'm going to say, hey, there's a format exception. You've passed in that type, but the method doesn't have the supported dodgy model that I'm going to pass. However, if that's all good, saying it's constructing up a new one, it's going to read the stream, and it's going to do some string magic just to get into a nice object for us. And then I'm going to return that model, which is within that task. So it's returning a task, in this case, of dodgy object, but obviously everything casts down to object. And eventually that then gets passed on to our action method. So this is our media formatted here. Again, we're saying, all right, the type that's coming in is dodgy model. And if I have a look at the requests, let me just call it up. And run that. Look at that. Let that run through. Executing the custom binding, we're doing a post. And the content type is application XDodgy. And if we go down a bit more, there's the request payload in there. Okay, so it wasn't JSON, it wasn't XML, it was some custom thing. And in this particular instance, we want to put it into a nice action method. Again, it's all about bringing up some nice action methods for us, so we get this nice strongly typed object. So we get this rubbish that comes in, but we're giving it a nice object for us to deal with on the server side. Is that clear so far for everybody? Delegating handler pretty much deals with everything. The media type formats will deal with a specific media type where the format is kind of custom or unknown. Okay. Model binding. So the next one kind of down in the stack is model binding, and this is what sort of WebApi does for you as well. Model binding is a bit more flexible in that you don't have to worry about reading the body and all that kind of stuff. You use the inherent value providers, which is kind of the same thing as MVC, but you don't have to worry about taking a copy and having all that safe aspect for it. You can just use the value providers to read the data from the URI or from the body and stuff it into an object, and it'll just work. You won't have to worry about it. So there's different ways you can specify it. You can have a model binder attribute type of a particular model binder on your action methods and parameters, which kind of gets a bit messy. I mean, it's really personal preference. If you want to have all these attributes on your action methods, it's all good. It can get a bit unwieldy. You can register a model binder provider which will provide a model binder for the web API to use. So it's kind of one level of indirection. You register the provider. In the provider, you determine what model binder and then provide an instance of that. And I'll show you how to do that. This is kind of my preferred approach because it just happens. And from a web API perspective, you can just specify your action arguments and it'll just stuff it in there without, you say, a dev having to worry about attributes on your action parameters. There is this iController configuration interface, which is quite low level and gives you access to everything like route tables, formatters, binders, so you can get quite low level with it. But you know, I haven't had an instance to use it yet, but the option is there to customize that. Okay, so with in this particular instance for demo model binding, I'm going to assume that most people want to do paging. So we're going to specify things like paging arguments. And we're going to have a paging info object, which is strongly typed. So we want to kind of make sure that anytime this is specified on the URI, we can get the correct paging info, but also be able to work with other parameters as well. So if I get with no paging parameters, let's get out of here. Oh, sorry, let me just run that again. Yes, so there's a URI. No query arguments in there. If I execute that again, come on, come back to me. In my paging info here, you can see I've got a page of 1, page of 25, and I've got no particular sort fields in there. So I'm just, again, the goal is just to try and make a nice strongly typed paging info here. And with some paging arguments, I'll explain the model binder in a second. We have a look at this. We've got a page of 2, page size of 40, and we've got some sort fields of name and age. So it's getting in there okay. Let's have a look at those requests. So here's the request I've just made. Page equals 2, page size equals 40, sort fields equals name, pipe, age. So I was able to pass that out and put that into a nice strongly typed object for me. Again, all about nice action parameters. Now, in order to hook all that up, like we've done previous, if I go, this one's a little bit different to hook up actually. Oh, there is, sorry, I should clarify. You can just add into the global configuration like you normally would. In this particular instance, I'm using dependency injection and I'm using Ninject. Is everybody familiar with the concepts of DI and tools like Ninject to do that? Anybody not? Yeah? Okay, so what we're doing is we're just saying we've got a particular type of object, which is a model binder provider. When the runtime asks for model binder provider, we're going to sort of map that to my custom version. So I'm just sort of mapping my custom version for when the runtime asks for just this specific model binder provider. So the runtime will always ask for that as part of the request pipeline, but I'm injecting my custom version there. So if I go down to there, I'm going to say, okay, my model binder provider inherits from model binder provider, and if the type that's being requested is paging info, I'm going to return a new instance of this model binder. So again, this is kind of like a factory for your custom model binders. In the model binder, this one's very similar to MVC. I'm implementing iModel binder, and there's a bind model that I'm implementing. Takes in an action context and a model binding context. And here I'm using, as I mentioned before, the value providers. So from the binding context, I'm getting the value provider for page. And if we go down a bit more, using that to get the page size as well. And I default it if it's not there. And then with the sort fields, I get out the sort fields and then I do a string split on the pipe character just to bring it all into a nice object. So once I've got all that split out into a nice strongly typed object, with the binding context model, I assign that to the object. Return true, and then it shuffles it off to my on my action argument. So again, that stuff's reasonably similar to MVC. Again, the whole point is to get that paging info as a nice action argument into my controller method. This part here, this Model binders should be fairly familiar to you if you're with MVC. The model binder provider, however, is something that probably not so familiar and is the preferred way, as far as I can make it from the team's direction, to provide model binders. It's a bit of a level of indirection, but it's the way they like. Finally, if I go back up here, custom binding, model binder. This also works with, if I've got other arguments there as well. I've still got a paging info. So if I go back to my demo, get paging args with other args, goes into my model binder. You can see my paging info has page size and sort fields all defined. And I've also got stuff as blah as well. If I have a look at the request, here we go. Stuff equals blah, sort fields equals name and age, page size, etc., etc. So it was smart enough to pick out all the items for the paging info, and because I didn't explicitly deal with that, and said, hey, that's cool, I'll take that stuff and stuff it into the argument for you. So I only had to do the amount of work necessary. Is everybody okay with that so far? So in the model, this is at the model binder, so we've gone from delegating handlers at the very top, the media formatters, a very specific type, now model binders, where it's probably the more common scenario where you've got maybe a JSON object or XML, you want to stuff it into your strongly type object. However, what about if I disabled the model binder and just let the Web API kind of work it out? So let's do that. So I'm going to take it out of dependency injection. So it's not registering my custom provider to give a model binder for. And we'll see what happens. Okay, we're back up. Come on. So I'll call this method again. So we come in here, we say, oh, we've actually still got an object, sorry. We've got page is 2, page size is 40, so it's kind of worked that out for us. Have a look at the sort fields, we've actually only got one, and it's name, pipe, age. So it's kind of done its best to work out that it's got page, page size, and sort fields, but it's not smart enough to split out, do that pipe split, because of course it has no idea. It has no idea you want to split it on a pipe. Does that make sense so far? So WebAPI has actually done a pretty good job of working it out, but it only got so far. We still got stuff in there, by the way, too. Yes. On the paging info, I have been very explicit and put that from URI attribute that I mentioned before. So I'm saying this always comes from the URI. If I take that off, come on. All right, we're back. Now if I execute it, coming in here, paging info is null. So we had to explicitly tell it to come from the URI. It couldn't find it, wasn't in the body, because it was a complex object. So it said, I don't know where to get it from. So we've accordingly got null in there. Still got stuff, just no paging info. Okay, everybody okay with that so far? I know I'm bouncing around a fair bit. Okay. Who's familiar with OData? Few? Okay, it's kind of a way of dynamically querying for data via a nice query string. And very, it's kind of a standard way of doing it, almost. In the release candidate version of WebAPI, OData was supported out of the box, but it was only a small section. I think there was like filter and top and a few other words or verbs out of the OData dictionary. When it released, they subsequently removed OData, so it's not in there at all at the moment. However, their plan is to support OData via just a NuGet package, and I think there was an announcement, I can't remember exactly where, on Codeplex somewhere, that they're just about to release the OData NuGet package. So you'll be able to do something similar like, and I had a demo for this in the RC, but now it's pointless. implement iQueryable and put a queryable attribute on there. And as long as you return that iQueryable, it'll just support OData out of the box for you. And you won't have to really do anything apart from return this type and put this attribute on there. So it's pretty powerful stuff. There is this NuGet package, which is still in alpha, but I suspect will obviously be superseded by their new NuGet package. This alpha package does require you to do a little bit more work, and it's a bit crappy to set up. It works, but I'd only sort of do that if you were bored, were interested in paying, those things.
Dangerous is OData in terms of query injection, query databases.
There's always an element of risk because you are increasing your surface area. But I wouldn't advocate just opening up your database and allowing just carte blanche sort of access to it via OData. There would certainly be use cases for using that. So it just says, for those cases where you can provide some data, some nice queryable data, just make it OData available and let your customers sort of suck it up how they want to suck it up. But ultimately, yes, it could be a security risk depending on how much you opened up. But that's more of a conceptual thing. That applies to sites, API, everything like that. OData is just a bit more visible.
What's the reason OData is so popular? Why do people like this so much?
I don't know, to be honest. I mean, I guess it's just a standard way of accessing data. Also, there's a lot of tools out there that support OData. I haven't used it a lot. I don't know about yourselves. Has anybody really used OData out in the wild? Yeah? And what did you use it for?
We provide an API through it, and you can write link queries against it.
Yep. But is it over the entirety of all your data, or is it just a small subset that you're showing?
At the moment, we're using it for all of our data.
Yeah?
So we let our clients query our data through this.
And what's the uptake? How many clients would use it? Sorry, Adam? Oh, okay. So, so you were saying that all your clients, you've provided it for all your API. How many of your clients would be using it?
It's early days.
Yeah.
These are enterprise clients, so they're integrating their systems with our systems.
Mm-hmm.
Probably got about 5 clients on there.
What percentage are those 5 clients out of your total user base?
That's probably about 5%.
So I'd expect that. So a reasonably small percentage. I mean, people will probably use it to find out how it works. Can they make it work for them? Maybe good for just analysing the data and doing their own forms of queries and presentation based on that. So it kind of can take a bit of the workload off you. Here's the data. Do what you like with it. We'll build the basics. You can go off and then form it how you want to. So I see it as being used for that. But again, I think it's early days for that. Okay, dependency injection, talked briefly about it before. Again, very similar to MVC. It uses MVC uses iDependency resolver. WebAPI does use exactly the same name, but the WebAPI is a little bit different. It has this support for things called lifetime scopes. And dependency injection is a fairly complex thing to explain, but the lifetime scopes in concept, the reason why it's different from MVC and supports these lifetime scopes is that it can more aggressively manage particularly resources that, say, implement iDisposable. So we can create child scopes with a group of iDisposable components, and as soon as that child scope is gone, it can release all those resources rather than having everything rooted at the very top of the hierarchy and have to hold on to all these iDisposables for the entire lifetime of things. So it enables it to more isolate and compartmentalise usage of iDisposable resources and release them in a much more granular basis and therefore manage memory better. Just to show you the difference. Okay, we saw here that I'm hooking up Ninject. Now, the normal MVC way is just here doing a set resolver. I'm newing up an inject dependency resolver. That's good. With the Web API, I'm creating this new API dependency resolver, and I'm assigning that to the global configuration dependency resolver. If we have a look at that, the API dependency resolver implements iDependency resolver, but iDependency resolver itself also implements iDependency scope. So there's actually two interfaces that's why it's different to MVC. The lower level interface implements what you'd normally expect, which is what you're probably familiar with MVC, get service and get services method. But this higher level one implements this begin scope, and then we talk about this lifetime scopes. And this is how it can create these child scopes and manage this iDisposable references much more aggressively. Again, it's a bit more of a complex topic. There's a guy called Nicholas Blumhard who knows a lot about it. He wrote AutoFac, and he's written many blog posts on why lifetime scopes are a good idea. Quite complex, but highly recommended reading. And it, implementation-wise, it's not so hard to do. But understanding the whys and how it all works under the covers, there's a bit more to it. So I'd recommend reading that. The thing to be aware of, though, is that don't get confused with MVC, iDependency resolver, and WebAPI, iDependency resolver. Same name, same spelling. The two are distinctly separate, though. So and that's where I mentioned before that you'll see some sort of overlap and think, how come I've got to do it here and do it over there? They're exactly the same friggin' name. Just give me the same stuff. They're actually completely separate, even though the concepts are very close. Okay, authentication, authorization. Similar to MVC, you can specify authorize and allow anonymous on your methods. In somewhat different to MVC, you don't have a web page to go to there, so you do have to make sure that when you do specify, say, authorize and the person's not authorized, all they're going to get is a 401 back, a HTTP 401, saying that they're not authorized to do it. They're not going to be redirected to a page or anything. It's an API, remember, so your client has to be smart enough to say, oh, I'm unauthorized, should I go somewhere else, or what am I going to do now? So you're just providing that HTTP status code back. You can provide your own authorized attributes if that's the way you want to do it. You can inherit from action filter attribute, and this is all very similar to MVC in concept as well. I mentioned that the 401 result needs to be handled by, or at least understood by your client. Again, it's not a web app. But I also talked about the delegating handler before, which is right up the top of the stack. And you can also handle authorization there, and that's what we'll have a look at. Actually, before we'll have a look at the attributes as well, so I'll just go in there and do a quick look at that. It's not very exciting, but it's important to know. So I've got test auth controller. I've got an authorize on the get method, and I've got an allow anonymous on another get method, but with accepting a string auth argument. So I'm going to fail the authentication. Actually, before I do that too, just go up here. There, refresh. You can see down here, I got a 401 authorized. The URI I was accessing was API test auth. So that's gone to try and access this method here, and I'm not authorized, so it's sent me away. However, if I put that auth parameter on there, no thanks, you can see I got in OK. Got a 200 back. The only difference was that auth parameter, which matched up with this guy here, was allow anonymous. It's all good, allowed us in. So that's pretty easy. However, if we wanted to hook it up with a delegating handler, and much in the same way that we've done everything else, message handlers. So in the global configuration message handlers, I'm adding in an instance of my dodgy authentication. My dodgy authentication is a delegating handler, so we're inheriting from that, and overriding the send async method, returning a task of HTTP response message, getting a request and a cancellation token. And all I'm doing is saying, all right, if the URI contains this test auth handler, then we're going to perform some special authorization. And my extremely complex algorithm says if it's isGlav equals true on the URI, then we're going to let that in. If that's not on there, then we're going to fail it. So I go up to my demo. This done is good. Now if we have a look at that, the secrets of the universe are revealed here. So I've got isGlav equals true there. Again, I'll just refresh that. You can see down here to 200, all good. If I take that off, okay, I've got a 401. So that's right up there in the stack. And again, that's my delegating handler that's executing before any of my controller actions are being executed. So that's like the the foremost gatekeeper. Does that make sense? Yep. Okay, moving on. Okay, so advertising or self-documenting. What the Web API gives you is a way to examine all the metadata within your Web API. So it'll give you this API Explorer object, and it's already done the hard work of sort of interrogating your API, finding out what methods there are, what verbs they support, the type of arguments, and a whole bunch of other stuff. What it doesn't do currently is provide a default page for you to throw up and display. I think it will in future revisions, but currently it doesn't. So what we can do, if we have a look at this, if I do get help text, you can see I've got my path, beer, kind of beer, which we saw earlier on, and once a get, the description currently is just a placeholder. I'll talk about a bit more of that in a second. It takes in a string with a kind of beer parameter. We've got an API slide, we've got API custom bindings, API simple, which we saw before, and doing all those get methods on. So we've got a whole host of information there. I've got a different way of showing that via a page. Again, not too bad. The way I've gone and done that is in my Explorer controller. I'm saying, all right, from the global configuration services get API Explorer, I'm going to grab all the description from that and enumerate over those descriptions. And I'm just, in one case here, I'm just constructing up hard-coded HTML. I'm getting the relative path, the HTTP method, the documentation that goes with that. I'm also going through the parameter descriptions for that particular API description and picking out things like the parameter type and the parameter name. There's a whole host of other things you can use there and extract out. In one of the other versions, where was this? API help controller. The other way of doing things is I can get an Explorer, an API Explorer, like I did before, and just pass that straight to the view. And in the view, you could just iterate over it as well. And that's all I did in this particular one here. This one here was just where I was forming up the hard-coded XML. Okay, so you've got all this rich metadata to grab out for you. But again, you've got to form up your HTML to display to a user or however you're going to display that. If you don't want to expose something as part of that metadata, you can apply that attribute to it. So ignore API equals true, and it won't appear in that list of metadata for you to display to whoever's consuming it. Also, I did mention that the description currently is just a placeholder at the moment. It doesn't know how to create a verbose description of your action methods. It's got no idea. It just knows the technical details about it. So it's really up to you to provide documentation for it. And there's a few ways you can go about it. Ultimately, it uses this thing called an iDocumentation provider. And by default, it will give you pretty much what you saw up there, just a placeholder. Oops, sorry about just for the purposes of demonstration, I'm putting in my own custom documentation provider, and doing that by global configuration services, replace this interface type with my custom Docker provider. If I have a look at that, it's just implementing that interface, and there's a get documentation method, both of which, or two of them, sorry, both of which when it accepts an action descriptor and a parameter descriptor, and you can provide what you want from that. You can access the database, for example. You can do pretty much whatever you like. In my particular instance, I'm just returning a hard-coded string based on the action name. Nothing too exciting about that. Luckily, a guy called, I think his name's pronounced Yayo from Microsoft, has gone to the hard work of creating a documentation provider based off XML comments in your code. So if I run that up, let me close some of these down. Once that's finished, okay. Now if I refresh this, you can see demand a serving of your favourite amber beverage. There's no documentation found there. Dodgy demo of binding some dodgy data to a dodgy model. This is all stuff that I've placed on the XML comments. And so it was, all I did was simply plug that class in, added some XML comments, and I was good to go. Which is pretty cool. The actual XML comment documentation provider, I certainly can't take credit for. It's a little bit meaty. Okay, there you go. Did you get all that? However, all I did was copy it straight off the blog, whack it in there, and she worked well. Again, all this particular code is all available for download, so you'll be able to use the same thing, or just go to this this side here and pick it off. So it just kind of demonstrates the some of the interception points and how you can sort of go about customizing your web API. I think the XML comments is probably a reasonable way to do it. Again, you could still do it by the database, or you could use some dodgy SharePoint CMS thing to manage your documentation. Okay, moving along. Self-hosting. The Web API, again, I mentioned earlier on that it has no reliance on MVC. You don't have to host it in IIS. You don't have to host it in an MVC web application. You can host it in a console app. Really doesn't matter. It's quite easy to set up your own self-host. This particular demo is not overly exciting, but I'm going to open up a host that I think is port 80,000 or something like that, and use the same controls to serve requests. But it's just going to demonstrate how easy it is to set up your own self-host. You've got to install this particular package, which gives you all the self-host references that you need. We create a self-host configuration instance with a few things, and then you pretty much just start it up. Again, the demo is not particularly exciting. We've accessed a method, but what I'm doing is I'm at localhost 8000. Okay, there's nothing waiting there. I'm using the self-host path. I'm accessing the simple controller, which I defined elsewhere, but using a completely different host, this one at 8000. If I go have a look where that's constructed, which is probably the more important part of it all. So you could do this in unit tests, for example. You could construct up your own host for the purposes of testing. I'm determining what host I'm using. I'm going to say I'm going to create a new host configuration at this host at port 8000. I'm going to set up a basic HTTP route for it, and then in a task I'm just going to create a new server. I'm going to grab an open task from the open async. I'm going to ask that open task to wait, and I'm just going to remain in the cycle forever, where that task is operating in the background, mind you, so it's not blocking. And that's pretty much it. That's how you create a new self-hosted instance of WebAPI. So it's pretty easy to do. And again, if you didn't want to use IIS, or you just want to spin up something for your integration tests, it's quite a good way of doing it. So you wouldn't have to spin up, another web instance and have something else accessing it from somewhere else and get this sort of synchronization issue between your proxies and your server. You can just do it all pretty much synchronously for the purpose of testing. Okay, almost at the end. I mentioned before the WebAPI inherently supports this task-based programming model, so if you're not familiar with the tasks, you soon will be after working with the WebAPI a lot. Now this demo is probably the most boring demo of the lot. What I'm going to do is access a page which is kind of going to spin around for 3 seconds and come back. Consuming this particular API method or this demo is not very exciting. If, however, I look at the code, async test, I think that's the one, yep. So the only difference I've done here is I'm returning a task of string instead of a string. And I'm starting up a new task of string, and in that I'm going to wait for 3 seconds, and I form up a string with the internal task ID and return that. Again, from the consumer's point of view, if I refresh that again, 1, 2, 3, eventually come back. It's just a synchronous access. But under the covers, the request has come in, the WebAPI said, oh, look, this is actually a task. So I'm going to spin that off, get that IO thread, give that back to the system so we can continue to service requests. In the meantime, this 3 seconds is sitting there and fart-assing around in the framework somewhere. It eventually finishes and come back, and the WebAPI says, okay, I'm going to put that back to that original request, marry that up, and give that back to the consumer. So it still looks synchronous from a consumption point of view. In terms of scalability, we've made a really important decision to release that IO thread to service other requests and increase the scalability to a large degree. Now there is a small marshalling cost that comes with that, so you probably don't want to put task of whatever on every single method, because it does have to marshal out to different threads potentially and then marshal that back, synchronize that back. So if, and I don't know what a good number is, but particularly if your API calls are taking, or a method is taking greater than a second or a few seconds, that's a good candidate for returning a task and just reaping the benefits without really having to do anything. It's as simple as putting task of that on there and returning a task. It's very easy, but again, has significant scalability benefits. So that's about the end of that. There's a few resources here. This guy, Think Texture, they've created a repository of WebAPI stuff. There's things like JSON-P formatters, loggers. The logger that I showed you there has been improved somewhat, and I added that to there. There's a whole bunch of people that have contributed to that, so there's a whole bunch of freebies you can get from that. You can download that. The WebAPI bloggers.com, there's again, a good bunch of guys that contribute just WebAPI related stuff and some quite complex stuff. So there's some really good content there. I already mentioned that you can access this online at any time. And here's where the source code is located at. So the only one you really need to worry about is this here. As long as you get that URL down, you'll be able to browse this content and get to all the URLs and all the associated content with it. So that way you don't have to memorize everything. Just one URL is all you need to know. And provided Azure doesn't bugger up my site, it should all be good. I think that's about it. Yep. So that's about all I've got for you. I hope it was informative. Is there any questions that you might have regarding WebAPI, or I don't know, hair care, anything like that?
Lack thereof.
Oh, lack thereof. All right. Well, that's about all I've got. Thanks a lot for coming along. Thanks to Adam for having me here. And I guess I'll hand it back.